As Christoph said, I'm Francisco, working for g.tec since 11 years, and today I'll be presenting my third lecture of the spring school. Always exciting for that, especially because this topic is a current topic that a lot of labs are interested to participate at. And we will be going through a bit of the basics, checking through some of the hyperscanning projects that already occurred, and to explain a bit how this can be done. At the end, we will do a session, a practical session, where I will have several of my colleagues, including the company's dog, hooked at one PC. So this is important to know. And you'll be able to see how everything is running smoothly uh, and good. So what is actually hyperscanning? So hyperscanning is basically the simultaneous recording between users. So you have at least two users at the same time with an EEG device. Obviously, you can also record other kinds of biosignal like EMG, ECG. You can have sensors also hooked in. But what is most important is that you are having more than one subject being recorded at the same time, and you are able to detect all the biosignal at the same time into one recording. So what kind of applications of hyperscanning are typical? So you have, for example, education. So you have a lot of papers that we've seen published on this topic. So you have, for example, a lot of a classroom full of students. Each of the student has an EEG cap, and the teachers are able to detect if one of the students is distracted or if they're all synchronized and being attentive at learning. And this can give not only the teachers, but also show the ways how to improve these kinds of applications. You have entertainment. So one big example that I remember is, for example, Dolby, who was testing with our devices how their sound system works to people by just measuring several people looking at the screen, the cinema, doing different kinds of experiments for having, for example, sound that is realistic. For example, they wanted to replicate the sound of fire, and they wanted to do it in the most realistic way. And the only way to know actually that this audio system works properly is measuring biosignal, right? So you can detect if the person is, for example, feeling nervous, if there is an increase of engagement of the subjects when they are watching a movie or listening to a sound. And this can be information that is very, very useful for these kinds of companies working in the entertainment industry. You also have, in the case of healthcare, to detect if there is, for example, changes in the biosignal of different patients or in different healthcare units. You have obviously a big role for this in marketing, where you want to see if, for example, a TV ad is widely receptive by the people that are watching at the same time, or, for example, you want to measure that several people are going in a supermarket, which of the products calls more attention to this person, which positions of the products in the supermarkets are better for the person to be able to see and want to buy it, etc., etc. So you can see a lot of different applications that you can use this kind of hyperscanning. But what is so as I explained, you could already see some very definitive samples of what you actually want to do. So what kind of applications can you do with hyperscanning, and how they should work? So one of the biggest techniques is actually to have a same task for multiple subjects. Like I was mentioning, person is looking at a movie, and then you have different people looking at it with different kinds of EEG, because everyone has their own EEG or an own biosignal, and you want to have a view of how different subjects react to the same different task. You can also have a same task applied, for example, to enhancement of accuracy. We will see an example. So a BCI application with hyperscanning is possible, where you have a lot of people with different EEG devices trying to reach the same goal, to write something, to select a character, etc., etc. So they're trying to perform the same exact task. And then you also have the social interaction studies where different people are trying to do different things, but trying to communicate non-verbally, and you are able to see how they actually react just by looking at the EEG. So some of the initial papers about this were already happening in the 60s. So we have this extrasensory electroencephalographic induction between identical twins, where two twins were having two EEG caps, and this lab was trying to measure if there would be any kind of synchrony between the alpha rhythm in both of them at the same time. And this is only possible, obviously, if you have a hyperscanning setup. So what do you actually need for a hyperscanning setup? First, you need a lot of users, so you need more than one user. So as you can see here, we have electrode caps, different caps for different users. You will put them, you can select very different ways to place the subjects, either in a row, like in a cinema. You can have them in the same room doing different stuff. But what is important is that each one of them is their own EEG cap, sending information to a control PC, or many if you want. But the important thing is that there is then a main recording PC getting the information from all of them, so that then you can do an actual comparison between the EEGs of the different people. So you need a lot of stuff for your lab, but the most important thing is that you're able to identify and to actually use this kind of setups to find important or information about the different mental status of the subjects. One very good cooperation study that exists is this one done in Italy, 2016. So you can see also our G-USB amplifiers here on the back. Let me just exactly here. They are hooked to two pilots, and they are in a simulator. And this paper's role was to investigate how good the synchrony is done during the typical flying tasks of starting the airplane, doing the startup, flying the airplane, takeoff, cruise, and then landing. So this was basically what they were investigating. So they were simulating a flight between Rome and Pisa, where they had a takeoff. We were measuring the synchrony between the first officer and the co-pilot. Then we had the synchrony in the cruise state, where they are not so active, to see if there is anyways a synchrony there. And then on the landing, which is a highly intensive task, and see if the users were able to actually work together, and not only as a team, but also on their brain activity. And this was basically what they have seen from different subjects. So you can see, for example, at a takeoff between three pairs of pilot and co-pilot, we have seen a synchrony between all these three pairs. And then on the cruise state, the synchrony was a bit more relaxed, because they're not so overwhelmed with tasks, and they can just relax a bit. But then on landing, we can see the synchrony is extended, so highly concentrated. The same areas are activated on the two different subjects. And if you look at also the frequency bands, we see a lot of different reactions. So for example, you see takeoff, cruise, and landing on the theta band, where you have on the takeoff and the landing a high response and synchrony. So you, especially on the landing, the same thing on the alpha band, where you have takeoff and landing, and cruise less. And with this, you can identify that the different pairs of pilot and co-pilot did indeed present some synchrony between the tasks. Then in terms of brain-computer interfaces, how can we apply hyperscanning to brain-computer interfaces? So the typical brain-computer interface requires a subject with a EEG cap, a brain-computer interface that is acquiring the data and trying to process and classify it correctly, and then a control signal that is showing, that is trying to translate this intention and sending this control signal to an external device. In hyperscanning, instead of one subject, we'll have many subjects. The most important thing is that they are doing the same task. Otherwise, the PCI will not have correct accuracy. So this was a project that we did many, many years ago with the question of, can people work together for a BCI and actually improve the accuracy or the speed of the system? So what was our goal was to use one single trial per subject. We had several subjects hooked in, and we were trying for them to perform a spelling task. So we already predefined the word. We knew what everybody had to select, and we were checking if, even though we had 8 people, always with the same montages, looking at the screen, if they would be able to actually select, and then we would have a look at the classifier, check who was the worst person or the least, the person with the worst classifier and the best classifier, and if merging everything together, you could have a more accurate average of the classification for the PCI. So we used in this case 8 channels, recording in the typical visual cortex montage for P300. We recorded this data using a GUSP amp with 256 hertz of sampling rate and a bandpass filter of 01 to 30 hertz. And we had a training application with 9 letters. And then we were trying to write Merry Christmas with this view. So as you may already know, because we've talked a lot in the past 3 days about the P300 and the different PCI techniques, people were trying to identify or select a character that was flashing on a row and column pattern. And we were trying to see the P300 on each individual user. And then we can see that the person was able to, or is wanting to select a character based on the averaging of all the trials, which the selected trial will have a higher peak compared to the averaging of the other ones, which should be close to baseline. And this was the video, so you can see some of our employees in a very young stage of their lives, some with less gray hair, some with more hair. So you can see everyone sitting in front of the screen, trying to select different characters. They were using Ladybird, several USBMs, so you can see set up with a lot of cables. This is something that we will show that it's not necessary anymore. And they were then writing Merry Christmas to all the subjects. You can see this video on YouTube. It's still uploaded there. So you can go back 12 or 15 years, scroll down all the videos, and you will find this video on YouTube. So you can see people were able to select. They were looking at projector on the wall and selecting the characters. So it worked very good. It was one of the first experiments. We had best subject with 100% accuracy already in around 3 flashes. We had worst subject who had around 98 at around 10 flashes, but had difficulty in keeping that. But if you merge all the subjects together, you see that you reach 100% accuracy around 1 to 2 flashes, which is fantastic. So we were able to really show that this is possible. Hyperscanning for PCI is possible. Then let's go back on the history of this lecture on the Spring School. In 2023, we had cognitive engagement. We had different subjects, Sebastian, MJ, Michi, Johannes, and Ali. in different PCs connected to the network, and they were performing an engaging task, and we were able to see and discern in real time which of the persons were more concentrated. MJ was a highly efficient subject, I remember that. What they were trying to do was to select different characters. So you had the D2 task, which you have to look at all of these letters and select and click on the D and the 2 points. And to do it in the most quick manner. So you have a target, which is the D2, and all the other non-targets, which are the D3 or P3, etc., which are the users were getting a feedback if they did it properly or not. And then we had a comparison between the engagement with the feedback and the resting state. So comparison between these two different states. They also had a Tetris task where they were trying to perform the task, and we were able to see that the engagement, as the Tetris game started to be faster and faster, the engagement also increased. So it was very significant results for what we had. And this was a video of the of the experiment where you have MJ, very happy. I hope he will be happy today too. We have Sebastian. So this was the task. They had the resting state task. Then they had the D2 task, which they were trying to click. And you can see the time on the top pressuring them to finish as quick as possible. And then another resting state, D2 again. And then we were getting this feedback in real time on the Spring School with the engagement, with the photos of everyone. So in this experiment, the people were spread out across the whole company. Everyone is connected into the LAN. So we had a network connection, sending the information to the main computer who was doing all the processing. So you had different computers into the same network. Exactly. Last year, what we did was to use the same PC with different kinds of amplifiers. We had 4 people hooked in 8-channel montage on a high amp. We had then 2 people hooked on 2 different G.Nautilus, and we were recording it in a PC. That we did the same cognitive load exam with a fixation cross, and also with the D2 task. And we were able to see the difference of the engagement and rest. We were using Simulink to do all the synchronization into one PC, and with a feedback on the scope where if you had above 0, you had an engagement feedback, and if you had below 0, it would mean that there is no engagement, or there is the resting state, or classified as a resting state. And you can see the lecture still on our YouTube channel, where we had everyone sitting in front of a screen projected into the wall, and we had people performing these tasks. For this year, we actually started on the first day with a kind of a hyperscanning task, which was hidden within the sports lecture that I did. We had Evgeny and Katrin playing tennis, and if you noticed and if you're attentive, you had 2 different people using 2 different devices. This would be classified as a hyperscanning because they were performing the same task, and we were trying to see how the Oscar block was helping our model to achieve a very high quality EEG, even though they were moving a lot. So this would be also an example of a hyperscanning. So you got a taste before our lecture about it. And this is what we are going to do today. So we have several people. Each one of them is hooked to one G.Nautilus with 16 channels. So I wanted to show that all these cables are not going to be an issue anymore. And we also have Santi, the company stock, who is hooked to a BCI core. So you're able to also check that on our Simulink blocks, not only you can use the block of the amplifiers of g.tec to connect different devices, you can also connect external devices to LSL in a seamless manner. And this is basically it. I will ask my colleagues to go to the chairs and start to set up the devices. I will change the camera so that you can see all the action here of so many people. I hope you can see here. So we have 4 different subjects. I put them in the chairs because they're going to get their EEG devices prepared. And in the meantime, I will show you a bit of our models and how I am setting up this process. In the back, I don't know, maybe I'll go with the camera just for a second there. Let me just remove it here because I wanted to show you that. Let me see if I don't destroy anything with the cables. That Santi is also being prepared on the background. So, hello, Santi, can you hold it on Santi? Santi is being prepared too by Leo. And in the meantime, I am going to share my screen with MATLAB. And the first thing first is connecting the BCI core. Leo, is it already connected? Let's connect. So Santi will be hooked at the Unicorn PCI core recorder. This is working on our own application, which means Santi just disappeared, which means that we'll be able to record on our own application and then send the information through LSL to the Simulink block. I will now talk a bit about the model, which seems a bit complex, but it's pretty easy. I just wanted to have a separation of the evoked potentials because we're doing an experiment with a paradigm presenter auditory paradigm. We have a block here, as you can see, with the 4 different devices connected. They are sending the information to a MUX, which we will concatenate all the channels into one, and so that we can do much more easily the processing of the signal. Then we have the LSL receive block, which will receive the data from the BCI core, which will be running on the other application. And we have the paradigm presenter, which will run the paradigm that I have prepared. So it's a typical auditory evoked potentials. You guys will have to be attentive at the beeps, the high tone beeps. You will have to count it. These are considered the targets. And all the other beeps you will try to ignore. So it usually helps to count how many times the target will pop up so that you can have a high peak. I will just get back. Thank you so much. I will just put it into the holder so that if Kenny can rest his arms. That's good, that's good. Thank you so much. Let's see if I can catch all of you guys. Seems like, okay. I hope Santi will not run away from the camera, but will be very difficult. Yeah, so in this model, I have a selector because I want to see the EEG of each individual person. So the first Nautilus, 16 channels, second Nautilus, 16 channels, third Nautilus, 16 channels, fourth Nautilus, 16 channels. And then we have the BCI core, which will have the EEG information of Santi. I will then ask okay, Clemens is still preparing. So we have 4 different Nautilus with different electrodes as well. We have g.tec, G-Nautilus ProFlex with Scarabeo electrodes. We have a G-Nautilus with G-Sahara We have g.nautilus also with Scarabeo, but a multi-purpose version, and we have a g.nautilus with Ladybird electrodes, and we have BCI core with hybrid G-Sahara hybrid electrodes. Okay, let's wait that they are all prepared, preparing the things. I will stop sharing so that you can see better, and I will explore with the camera a bit more how the things are working. Oh, Santi is already have a nice head. He will get some sweets. The other subjects will not hopefully need the same sweets for being attentive. So you can see Santi enjoying the snacks. Yevgeny, MJ, Vasily, and Slobodan. No chocolate. So they will also get something to be concentrated. Great. This is how things work in g.tec. Exactly. I have all of the people on the screen. So they are sitting because, yeah, it's practical for Clemens to prepare all the caps, but in principle, they could walk around. Leo, is the device turned on? Okay, then I can already just connect it. Let's try to connect it. And we have it here. So you can see here the device. Of the EEG coming from Santi. So the EEG of a dog is obviously very, very different from a human. We also have seen this on the evoked potentials that we have seen on the studies that we did with animals. Let me have a look. Oh, I'm not sharing the screen, sorry. Wait a second. Let me share the screen again. Share the screen, sorry for that. Too many things at the same time. Yeah, exactly. So let's connect. And after connecting, we're able to see, for example, the signal coming up of Santi. And we will try to, not all the caps are prepared, but we'll try to run the model connecting to all the different devices. So I will stop sharing to show the camera again so that you can also see a bit what is going on here. So I have a device with the different Nautilus base stations connected to the main laptop, which is also transmitting my Zoom presentation. So we have one g.nautilus base station, two g.nautilus, 3, 4 g.nautilus base stations. You can see no cables in between the users and the computer, and everything should be working properly. Let me have a few. And yeah, let's go back to sharing the screen where the model is opening the 4 and is trying to find the devices. And we'll start with the paradigm already. So we can already see some of the EEG coming in. You can have a look at the potentials. So we can see already a bit, and we are able to see some of the traces going on. So you have a model running, as I mentioned. It seems like a very complicated model because it has so many different things going on. So you have a paradigm presenter doing the audio stimulation. You have the different scopes for EEG. You have the visualization of the EEG, you have the visualization of the evoked potentials coming up in real time, and then you have all the configurations happening. You will have a recorded file at the end with everything concatenated into one. The actions of the users are sitting on the chairs. Santi is now going wild. Let's see how the signal looks like with that. Let me share the screen. Let's go to Sam. This is more interesting. So you can get back. I guess she's far away because we lost connection. Okay. So we can see here how to select something that I think is very important to show is how you select the different devices, which I didn't show in the beginning, so that you have a more quick way overview of how to do this. So you have the different devices here, which you just have to select, and then you will go to the configuration file. And there you can do whatever you want with the configuration. In the case of the g.Nautilus, then you will have the information of the number of channels, of the network channel. If you want to add trigger values, in this case, everything is running on software based. So you can see here the different amplifiers on the top. This is a very powerful tool. I really, really like it. And then you can come here and then you just apply the filters. So 0 dots, let's put the 0 dots, 5 to 30 hertz notch filter and apply. Very good. First is done. And we go here and we apply also the same filters. You always have to highlight the channels, never forget that. Then you go to the next one and apply, apply. And the last one. Clemens, can you tell me just the serial number of the dry electrodes? Dry amplifier? 170885. Okay. One thing that is also important for the dry electrodes is that you have to increase the input range of the amplifier. So I just increased to 750 millihertz. And here you can see, for example, the network channels. So each Nautilus is in a different network channel. So if you're attentive here in the top, and that's all set up. And then you just select OK. And then you can start the model again. Also start the PCI core with Santi. Santi is rolling on the ground, so we'll have better EEG signal. It takes a bit of time to connect to all the different amplifiers because it's having a self-check. And then we will have the model running again, and then we'll be able to see the different kinds of EEG acquisition. But as you can see, it's very, very nice to have the power of all the people into one single model. Obviously, you can also add other stuff. You can modify the paradigm. So I'm doing an auditory evoked potential, but you could have, for example, also a model with visual evoked potentials. You could have different kinds of experiment. So you can see already the triggers coming up also on the Unicorn BCI core, but everything is running pretty neatly. You could have, for example, and I will just show you another way. You can have, for example, a Hosker model in between if you want that, for example, Santi to not have all these kinds of artifacts due to movement. Leo, maybe you can put something more close to the camera so that people can see. Because she's the star, so we need to accept nobody wants to see us, just Santi. It's always hard to convince Santi to move. It's 8 in the morning. We are all sleepy, including Santi. She wants to lie on the floor, so I'll just follow her. So also, okay. So that maybe we can show how the system is working. So you have Santis having the unicorn BCI core on the harness. You have a small cap. Santi, just turn around, please, so that people can see. So the harness is very comfortable. She likes it. She doesn't complain too much. It's the gold cup electrodes. She is not liking the camera. She's trying to lick the camera. So you can see we're having gold cup electrodes underneath. And yeah, exactly. So she's having a lot of fun here. The other subject's not so funny. But as you can see, we have a powerful model that can make it possible that we run everything at the same time. We can have auditory evoked potentials. We can have a EP scope running at the same time as the rest of the tasks. And this is a very good overview about how the potential of the system. What is highly important, and this is a question that many people have, and the camera is a bit twisted, but is that we have the possibility with the LSL seamlessly to connect with our amplifiers of g.tec. So if you would have another Arduino device, I believe Slobodan already showed something, or Alex, if you can have different kinds of applications, and you're able to select a lot of different kinds of tools together with our devices. Let me have a look here. I'll share the screen, sorry. I can see in the comment section that Santi is very loved. A lot of hearts and lots of art coming from you guys. So keep the love coming. Santi will read it afterwards and hopefully reply to the comments. What I wanted to show as well, another model that is possible is having, for example, Oscar applying to different devices. I am starting the model right now. So in this model, you will have different EEG devices also with Santi's EEG coming in. And you will be able to synchronize everything at the same time by reducing also the artifacts, which is, as you can see in the case of animals, essential. Otherwise, you have a lot of different kinds of artifacts coming from dogs. And yeah, trying to connect now. Connecting to one device, connecting to two devices. And then we start the experiment again. Auntie is more calm. She got enough to eat. And then we'll be able to see it. But it's very neat. You'll also be able to see, as I mentioned, the evoked the event markers directly on the BCI core. The BCI core is on the new version of the g.tec suite, which you can go to applications, and in the bottom you have the BCI core recorder. This is the software that is using, and then you can just simply connect to the core. You don't need, in this case, any kind of a dongle, but a Bluetooth dongle. It works pretty neatly with the Bluetooth that I have on my PC, and you can work seamlessly with other devices too, which is fantastic. Yeah. Okay, I think that would be it from my side. I will switch my camera to myself so that you guys can also see not only my colleagues, but also me. So thank you so much for watching. It was a really, hope it was a really instructive lecture, and you're able to see how you can combine all different kinds of amplifiers into one single model.
Thank you. You're also getting the gray hair like Santi
Oh
on your
yeah,
beard.
especially here.
How comes?
It's the time. It's the time. It's time for it. I just accepted it.
Natsmul wants to know, do you also show some sessions where you use brain-computer interface and the P300 speller?
We had in the this is such a very common technique for PCI P300. We could have done it, but because of Santi, that would be a bit more complicated. So we decided to go with auditory. But it's a very typical technique of PCI, and for sure we have opportunity for that.
We are showing a lot of these experiments during the hackathon on Saturday and Sunday. So there will be 2 days only of experiments.
Yeah.
Laila wants to know, does the signal acquisition method allow for combination with other modalities? So you add ECG, EMG, GSR, whatever?
Sure, absolutely. Can you come here, Evgeny? I can show you a bit of one of the possibilities. Please sit down. So then exactly, can you see the backside? So for example, this Nautilus, you're able to disconnect some of the EEG electrodes and you have a connector here. In principle, maybe I show with the other camera to have a zoom. In principle, you can just connect any kind of sensors together with this. So you have the connector, you connect the 1.5 millimeter touch proof, and then you can have ECG, EMG, you can have a galvanic skin response sensor, respiration sensor, etc. So you don't even need to do any kind of LSL connections with sensors because the cables are going directly to the Nautilus on the back of the head, and just transferring everything in real time. Obviously, it's synchronized because all the channels are being recorded by the main amplifier here on the back of the head. This would be one of the examples.
Thank you very much. Then Lenor wants to know, how do you synchronize the different devices?
So the different devices are synchronized on our block for Simulink. This is the main way to synchronize devices of g.tec. You also have the possibility of having LSL, which functions as a server protocol that synchronizes different kinds of devices into one. And then you can run into any application that you want using LSL.
Then Pablo is asking, how should he make a decision which unicorn BCI interface to buy? So what's in favor of a unicorn hybrid black or a g.tec unicorn BCI core?
So the unicorn hybrid black is very neat. It's a very compact device. You have the 8 channels. You have a cap with already the pre-positions. It works with the unicorn suite, which has a lot of software integrated into it. You can also use it on Simulink, for example, as I showed today. But if you want to have a ready-to-go package that you already you take it and you use it, the unicorn hybrid black can be very useful. If you're recording, for example, with animals, if you're going more into a more animal-based, research-based, I would recommend the PCI core. It has a higher sampling rate and a small and a very nice way to actually connect and disconnect. So this is the amplifier here of the PCI core. and then you have different base stations with different caps. This is something that discerns the two, and then you just connect it and it's active. I can already connect it to my PC. So if you want to have a more flexible unicorn, maybe the BCI core is the solution. If you want to have a compact, easy to go device, then the unicorn hybrid black will be your best choice.
Then Rudvish and Manuel are asking how many electrodes are on Santi's head?
We had today 4 electrodes. So we had 4. Do you have the device here so that I can show what she was hearing exactly? So this is the device that we used today. We had the 4 pin, the golden pin, so that you're pretty familiar from all the clinical appliances. It's just easy because Santi has a lot of hair, and we can just penetrate the hair, put it exactly onto the skin with a bit of gel and attach it very good. So she was using 4 channels with the PCI core. We add another option, which is, for example, what we use also with Santi, but with Forces. You have the hybrid black electrodes in the back. You have, for example, a purpose-made cap that you can put on the head of Santi, connected to the harness, and that's basically it. So this would be a kind of a hybrid dry electrode solution, and the gold cup is for more accurate, more precision-based recordings, especially if the dogs have a lot of hair. This can be very, very useful.
So maybe some people remember Manuel Alejandro from last spring school. So he was asking like 10% of all the questions. This year he promised to ask only important ones.
Oh.
It's funny. How many simultaneous signal acquisitions can you do? So how many devices can you connect?
Now with the LSL, you will increase a lot. So we have tested 4 different devices, but that doesn't mean that you're limited to 4 different subjects. As you remember in my slide, we had on last year 4 people hooked into one G.tec. So G.tec has 256 channels. You can connect a lot of people into that amplifier, and then plus that you can connect up to 4 tested devices. If you have the LSL connection, then you can also connect more devices of the PCI core, for example.
Now we have a very good problem. So the questions are getting more and more instead of less
Okay.
and less. And the most important take-home message is you have to feed your participants so that they stay calm and sit there. So I suggest Mannerwaffel. So that's the sweet that every Austrian knows. Whenever you're in Austria, get Mannerwaffel. Thank you very much, Frankie, for the nice
You're
presentation.
welcome. Thank you.
All the other guys, thank you. Santi, thank you.